Class 12 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 3 Calculus. Topic Differentiability. Subtopic Second Order Derivatives. Exercise 5.7. Second order derivatives. Let y equal to f of x be a function. Y equal to f of x is a function number. Then derivative of y with respect to x is denoted by dy by dx, and derivative of f with respect to x is also denoted by f dash x. Is called first order derivative of y with respect to x and denoted by y suffix 1. dy by dx ꯍꯥꯏꯕꯁꯤ first order derivative ꯅꯠꯇ꯭ꯔꯒ f dash x ꯑꯁꯤꯕꯨ first order derivative of y with respect to x ꯍꯥꯏꯅ ꯈꯪꯅꯩ. ꯃꯁꯤ denoted by y suffix 1. y 1 ꯁꯨ first order derivative ꯕꯨ ꯈꯪꯅꯩ. Again, d by dx of dy by dx. dy by dx asibu amuk derivative lower is called second order derivative of y with respect to x and denoted by d square y by dx square. Paba matamda d square y by dx square. Sigi d by dx of dy by dx for second order derivative of y with respect to x haina kawi. Masi d square y by dx square na khangnai or y double dash na khangnai or y suffix 2 na su khangnai or f double dash x na su khangnai. Second order derivative small 1 2 3 4 yamdrabada mo mari asida kuna denote tawani. Example, find the second order derivative of the function 1 log x. Log x have a function sigi second order derivative to n anisubada x cube log x amasigi function na 6 second order derivative to. Let us try. Y equal to log x apiba function na dusini y the x na derivative lower body we get dy by dx to y1 na khana rasi. Then log x with d by dx of log x is 1 by x. y1 jubo amok x na derivative lower body d square y by dx square do koino y2 na khana rasi. 1 by x as x na derivative lower body minus 1 by x square phangi. Maram masidagi y equal to log x ki second order derivative t minus 1 by x square. For question number 2, y equal to x cube log x. Both sides x na derivative lower body y dot x na derivative lower body dy by dx. That is denoted by y suffix 1. And applying product rule on the right side, we get first function remains unchanged into log x ki derivative 1 by x plus second function log x unchanged into derivative of x cube is thrice x square. Simplifying, we get x square times of 1 plus 3 log x. Again, differentiating y1 with respect to x, we get y2. And applying product rule on right side, we get first function unchanged into derivative of second function is this plus second function unchanged derivative of first function is this. Simplifying, we get 5x plus 6x log x. Exercise 5.7. Find the second order derivatives of the functions in the exercises 1 to 10. Second order derivative puto haibani 1 again 10 for here 1 gidamakta y equal to x square plus thrice x plus 2 implies y1 x the differentiating lower body for dy by dx is denoted by y1 and the x square ki derivative twice x thrice x ki 3 into 1 that is 3 plus constant ki derivative 0. Again differentiating both sides with respect to x y1 that d by dy1 by dx we get y2 phange twice x the right side x the derivative of 2 into 1 plus 0 that is 2. So the second order derivative to 2 phange. For Roman number 2, here y is x power 20. Therefore y1 is 20, x power 20 minus 1 is 19. Again, the differentiating both sides with respect to x, we get y2. For this 20 into 19 x power 18, that is 3it times of x power it, which is the required second order derivative. For question number 3, y equal to x cos x is first order derivative y1, and applying product rule on right side we get x into derivative of cos x is minus sin x plus second function cos x unchanged into x equal to 1, and we get this. Lastly, we get this. Applying among derivative law of x the both sides, we get for y1 is y2 family c product rule probability minus x unchanged sin x की derivative cos x minus plus second function sin x unchanged into minus x की derivative t minus 1. We get this, and the cos x की derivative minus sin x. Simplifying, we get taking out minus, we get minus times of x cos x plus 2 sin x, which is the required second order derivative. For question number 4, log x. Here y equal to log x. Its derivative is log x 1 by x. Again, differentiating both sides with respect to x. For y1 we get y2. For 1 by x we get minus 1 by x square. For question number 5, y equal to x to the power x log x. Differentiating both sides with respect to x we get y1, and applying product rule on right side we get this. Simplifying, we get this. Again, differentiating both sides with respect to x we get for y1 we get y2, and applying product rule on right side, first function unchanged into derivative of second function plus second function unchanged into derivative of first function is twice x. Simplify, we get 5x plus 6x log x, which is the required second order derivative. For question number 6, here y equal to e to the power x sine of 5x. Differentiating both sides with respect to x, for y we get y1. Applying product rule on right side we get first function unchanged into cos 5x into 5 plus sine 5x remains unchanged into derivative of first function, that is e to the power x. We get e to the power x times of 5 cos of 5x plus sine 5x. Again, differentiating both sides with respect to x, for y1 we get y2, and applying product rule on right side we get first function unchanged derivative of second function plus second function unchanged derivative of first function, that is ex. Its derivative is ex itself. Simplify, taking out ex we get this. Question number 7, it is here y is equal to e to the power 6x cos of 6x. Applying or differentiating both sides with respect to x, we get y1 equal to applying product rule on right side, first function unchanged derivative of cos of thrice x is minus 3 sine of thrice x plus second function cos thrice x remains unchanged into e to the power 6x. Its derivative is 6 times of e to the power 6x. Taking common factor e to the power 6x, we get this into this. Again, differentiating both sides with respect to x, we get for y1 we get y2, and applying product rule on right side, first function unchanged derivative of second function we get this plus second function unchanged derivative of e to the power 6x, that is 6 times of e to the power 6x. Taking e to the power 6x we get this, and again taking out 9 we get this. For I, here y equal to 10 inverse x, its derivative is y1 equal to 10 inverse की derivative t1 by 1 plus x squared. Again differentiating with respect to x, applying quotient rule we get this. Simplifying, y2 is for 9 log of log x. Here y equal to log of log x implies y1 we get log of something is 1 by of something into log x की derivative to 1 by x. Again differentiating both sides with respect to x, for y1 we get y2. Applying quotient rule on the right side, denominator remains unchanged at first in numerator into derivative of numerator, derivative of 1 with respect to x is 0 minus matter की function लेंगे into derivative of x log x is this, whole divided by denominator is square, we get this, which is the required second order derivative. For number 10, Here y equal to sine of log x implies the differentiating both sides with respect to x, we get y1. So sine of something is cos of something into derivative of something, that is log x. Derivative of log x is 1 by x. Again, differentiating both sides with respect to x. For y1 we get y2 into past function unchanged, derivative of 1 by x is minus 1 by x square, plus second function unchanged into derivative of past is this. Simplifying, we get this, which is the required second order derivative. Question number 11. If y equal to 5 cos x minus 3 sin x, prove that d square y by dx square plus y equal to 0. Let us prove. Y is this. Differentiating both sides with respect to x, we get 4 cos x, its derivative is minus sin x. 4 sin x, its derivative is cos x. Again, differentiating, we get 4 sin x, we get cos x. 4 cos x, it becomes minus sin x. And taking out minus, we get this. This is the given expression, that is, this bracketed expression is replaced by y, and transferring y in the left side, we get this. For y2 we have to put d square y by dx square, we get this, hence proof. For 12, y equal to cos inverse x, its derivative with respect to x is this. Again, differentiating both sides with respect to x. For y1 we get y2. Applying quotient rule on right side, we get denominator is square, denominator remains unchanged in numerator at first, into derivative of 1 is 0 minus 1 remains unchanged into derivative of root over of 1 minus x square is 1 by of 2 root over 1 minus x square into 1 minus x square derivative is 0 minus twice x. Simplify, we get this, which is the required second order derivative. In terms of y, we have expressed in terms of x, in terms of y, we get this, which is the required. Minus cos x divided by minus cos y cos x square y, which is the required second order derivative in terms of y. Question number 13. If y equal to this, so that x square y2 plus xy1 plus y equal to 0. Let us prove. Differentiating both sides with respect to x. For y we get y1. For cos of something minus sine of something into log x, its derivative is 1 by x, plus for sine of something is cos of something into derivative of log x is 1 by x. Multiplying x on both sides, we get this. Again, differentiating with respect to x on both sides, we have to apply product rule on left side. Past function unchanged, y1 its derivative is y2 plus y1 unchanged, derivative of x with respect to x is 1, equal to minus sine of something is cos of something into log x की derivative 1 by x. Then cos की derivative minus 4 sine of something into log x की derivative 1 by x. Multiplying x on both sides, we get this, and for right side becomes this. Taking out minus, we get 3 cos of log x plus 4 log sin x, which is replaced by y, and simplifying, we get this, which was to be proved. Question number 14. If y equal to this, so that this equal to 0. Differentiating y with respect to x, we get this. A is constant, A and B are arbitrary constants. Therefore, e to the power mx its derivatives m times of e to the power mx. E to the power nx its derivatives n times of e to the power nx. Again, differentiating with respect to x on both sides, we get for y1, y2. For this, m square a e to the power mx plus for this n square b e to the power nx. Then transferring, now left becomes left to the value visually. For y2 we have to put this value and minus m plus n times of y1, whose value is this, plus mn, the value of y original value is this. Expanding, we get 0, hence shown. Question number 15. If y equal to this, so that second order is 49y. Here y is equal to this. Derivative of y with respect to x is denoted by y1, whose derivative is 7 times of this 350. 3500 times of e to the power 7x minus 7 times of this is minus 4200 e to the power minus 7x. Again, its the derivative is with respect to x is this. 7 times of this is this, and the minus 7 times of this is this. Taking 49, we get this. This bracketed expression is exactly equal to y. If we replace it y, we get this. Hence shown. For number 16, if e to the power y times of x plus 1 equal to 1, so that the second order is equal to square of the first order. Let us find out e to the power y. Differentiating both sides with respect to x, we get e to the power y into dy by dx equal to its derivative is this. Solve dy by dx, dy by dx to solve to dy by the e to the power y na sundu solve to krabadi e to the power y, it is 1 by x, it is replaced by this 6 then dy by dx becomes minus e to the power y. Taking differentiating on both sides, we get this. Now e to the power y dy later minus e to the power y dy and replace the top which is the square of dy by dx whole square. Hence proof. Question number 17. If y equal to 10 inverse x whole square, so that this equal to 2. Let us prove. Differentiating both sides with respect to x, we get for y y1 and 2 times of 10 inverse x, but it is not x, it is function of x, therefore its derivative, that is derivative of 10 inverse x, is 1 by 1 plus x squared. Multiplying by 1 plus x squared on both sides, we get this. Again, differentiating with respect to x, apply product rule here, first function unchanged. Derivative of y1 with respect to x is y2 plus y1 unchanged into derivative of first function 1 plus x squared is 0 plus twice x equal to 2. 10 inverse is derivative is 10 inverse x, is derivative is 1 by 1 plus x squared. Multiplying 1 by 1 plus x squared on both sides, we get left becomes this. Left become this, right become this. Which was to be proved.